When concrete is cut or ground down, it creates thick, billowing clouds that can easily swallow up an entire worksite. You have likely seen crews working through this kind of haze. Standard dirt and sawdust settle predictably, but concrete dust behaves entirely differently. The aggregate inside the concrete is packed with quartz. When that quartz is fractured by heavy machinery, it shatters into thousands of shards of crystalline silica. This diagram illustrates exactly how small these fragments are. Because they are smaller than 10 microns, they easily bypass the body's natural respiratory defenses and lodge themselves permanently into lung tissue. At a microscopic level, these jagged particles are so incredibly light that they stay suspended in the air for hours, tumbling through the environment long after the tools are powered down. If the site happens to be near a humid coastline, the coastal moisture reacts with the suspended silica, causing it to quickly bond with almost every surface it touches. Clearing a site after a renovation is strictly a health and safety operation. Treating it like a routine cosmetic sweep leaves a real hazard behind. Trying to pull that fine silica up with a consumer-grade vacuum usually makes the problem worse. Consumer models lack completely sealed internal housings. The microscopic fragments slip right through the exhaust vents and are blasted directly back into the breathing zone. Professional remediation requires an H-class safety vacuum. This cross-section of the completely sealed internal architecture traps hazardous materials without leakage. Zooming into the filter membrane, it forces air through a dense web, blocking 0.3 micron particles with 99.97% efficiency. For the fragments that are too light to settle, crews run negative air scrubbers. These machines pull up to 2,000 cubic feet of air per minute, capturing the dust still suspended in the room. Without proper H-class filtration, the friction from brooms and standard mops simply launches the silica straight back into the air. Even after heavy debris is gone, a newly renovated space is often left with a deceptive, uniform layer of gray-white powder coating the entire room. Cleaning it requires a strict top-down approach. Crews start at the highest ceilings and bulkheads so that any dislodged dust falls onto contaminated surfaces rather than clean ones. This chart outlines the standard 5-stage post-construction cleaning timeline, from the initial rough clean through defect rectification. Notice the highlighted final clean row. It takes a dedicated crew 6 to 12 hours to bring 100 square meters to a safe standard. The required time depends on the materials in the room. A flat microfiber mop will smoothly lift white dust straight off a sealed hardwood floor. Porous surfaces like unsealed timber or fabric trap the fragments deep in their texture, requiring targeted dry buffing to pull the silica out without leaving wet stains. Carpets are even more demanding. The sharp particles work their way all the way down into the backing, forcing crews to run multiple passes of hot water extraction to flush them out. Every physical texture on site dictates exactly which sequence, chemical solution, and time frame the cleanup crew will need to follow. Once the visible surfaces are clear, there is still one critical area of the building left to address: the ductwork. During construction, fine particulate matter aggressively swirls toward the return air vents, getting pulled directly into the building's circulatory system. Even if the HVAC unit was switched off during the renovation, pressure differentials caused by the wind naturally draw silica through the grills. Warning tone: if ignored, you end up with an evaporator coil looking like this. The bonded gray concrete dust completely chokes the cooling fins, drastically reducing airflow and heat transfer. Clearing it requires dismantling the housing, HEPA vacuuming the fragile fins, and applying a chemical coil cleaning foam to dissolve the hardened residue. The longer that dust is allowed to sit and react with the coastal humidity, the harder it bonds to the equipment, and the more expensive the labor becomes to remove it. A true post-renovation cleanup has to address the airborne hazard, the embedded particles, and the mechanical systems. Doing so ensures the air is safe to breathe, and the building is actually ready